So I'd like to share my screen so that I can present, just use this as a guide to discuss what I want to. So how many minutes do I have? How many minutes?
Yeah, you have 20 minutes, sir.
Okay, I think I should be able to go through this within, and does that include the question and answer section?
No, sir.
Or that we take? No, okay. So essentially, so when we talk about engineering design is, that the word design is broad, and it's applicable to all field of engineering, from structural, process, piping, and mechanical. I'll try to start off with the uh, discipline. I mean, the courses we do in that are common in Nigerian university: material and corrosion, M&C, chemical, electrical, instrument, computer engineering, as the case may be. And typically, when you're in school, you just do design. And in school, design, if you follow the basic routine, it's simply a process a routine process. If you compare, the welders they put structures together, and as an engineer that went through university structured processes, you also put structures together. The difference you see is that in engineering design that follows that structured process, you tend to have a drawing that represents the product. Behind the drawing, you have engineering calculations and guidelines that are based on specific industry standards, which as we go along, you see that we have some codes and standards, regulatory requirements that are applicable to various engineering fields and businesses. So that's in a layman's design of engineering, definition of engineering design. Having understood that, then if you in the university, there are some common courses you do, subject to do in university that, for somebody that wants to pick up interest in engineering design, these courses should drive your interest. Like in drawing, as somebody that wants to do design, or somebody that is doing design, you must very, very comfortable with reading drawings, interpreting drawings, able to see in 2D, 3D, have a very good grip of material engineering, be very comfortable when they are discussing stress drivers, that is trying to pick interest in design, or somebody that is doing practicing design. These are common things you work with on daily basis. Hydraulics, maybe because I have mechanical background and process. This is also something you need to have at the back of your mind. For civil structure, it may slightly be different from this, but this just captures some basic and generic undergraduate backgrounds that you need to have, and you must be very strong on them. Plan design as well for people that do it. So, like I said, design to various have countless industrial and gas design. So what I was discussing, as we go through the item. For oil and gas activities generally, design is a component of a broad phases of oil and gas activities. For typical, if you want to outline it, for typical oil and gas life cycle activities, you have from the exploration, where you have the geotechnical, geophysical guys, handling that aspect. Then you have reservoir engineering, where you have the reservoir engineer. doing the assessing the reservoir. After the geotech guys will have established that okay, there's a oil reservoir somewhere. The reservoir engineers will go and make an assessment if that quantity is viable for commercial opportunity. Then after that is fully established, at this point, I'm not going to be speaking to how this broad groups of oil and gas activities is broken to how they interface. But as reservoir engineering is doing that assessment, predicting the volume of crude that is in the reserve, they are communicating with the project, the engineering team, project management team, telling that, okay, I have this much oil. If I want to produce it in the next 10, 15 years, how much of facility am I going to be needing? Those ones who advise and say, okay, based on what we've done in the past, this looks like the cost of the facility. Then the reservoir engineer with the other business decision-making folks goes back and do an assessment and say, okay, based on the volume of oil that this reservoir can produce, this is the amount of, that is at the very high level, where people that make business decisions do. But after that, then it goes to drilling when they are ready to actually produce the well. Drilling does that, then come the project team. The project team, they are the one that will construct the facility, design and construct the facility and install. They will design, procure the facilities, construct it and install it. Then after that, then another group of people will come that will operate it. So the field operation guys. So that is where engineering design in the oil and gas scheme falls in. So if you are doing oil and gas design, you are not doing reservoir, you're not doing drilling. You are supporting the project team to put together the facility that is used to produce oil and gas. And this is a very, in terms of criticality or who is more important than the other is a long discussion. But the geotech guys will tell you, if not for them, there won't be oil. Reservoir guys will tell you, even if we find the oil, how do you assess the volume is? And we tell them, no matter what you find, if you don't have a facility to produce it safely, you can't do anything. Operation guys will tell you, no matter what you put together, if you don't operate it and produce the oil, nothing is going to happen. So that's how we are interrelated. So and we work very closely to each other, especially engineering and field operation. Especially project team and field operations, because during the life cycle of the facility, we go back to each other and discuss how the facility is performing. If they have any issue during the operatory. So if you now let's talk about design. So I've been able to say that, okay, to establish the face of oil and gas general activities where design engineering falls is part of the project group. It may vary from company to company, but the company I work with, we are embedded in the project group because we do the design, we generate the drawings, specifications, document. We spec the materials that are required to be procured, and we hand it over to the procurement team to procure. During the procurement phase, we get involved heavily because maybe if you have opportunity to discuss, how this phase is also procurement phase and how engineer support procurement. It's something I did for a project that I was on some years ago. I was a primary engineering procurement rep in the procurement team. So then we now go to engineering design. What do you do? What do you do? I've mentioned some of the things we do as an engineering design team, but just to try to call it out more specifically. We do design. When we say design, we do calculation, we generate drawings. In some projects, you'll be seeing up to like 5,000 drawings or 6,000, depending on the size of the project. Even in some, you see up to 10,000 drawings. So engineering team generate those drawings across various disciplines: process, pipeline, piping, instrumentation, electrical structures, civil structure, marine, as the case may be. So we generate drawings, we do the designs, do specification for key materials. We we spell out the components, we do procurement support. When they are putting the construction scope of work and work back together, we make sure those are done as per our design. Our design, if for instance, you have a fragile material and construction is saying they want to handle it not with so much care, it is at that point you interface with them, you tell them, no, this particular component requires this level of care during construction. So those are the kind of interfaces you have with construction, because you did the design. They don't have much information like you do. So you need to be able to guide them, and that is where we talk about. Hello, up, I'm audible. Hello.
Yeah, we can hear you. Yeah, we can hear you, sir.
Okay, so we support them. Then when they are starting up the facility too, we are there to say, okay, these are the things we design. These are the operating parameters, guiding parameters that you need to watch out for. So when it started and it goes into full operation, then we are also on standby to respond to respond to uh, to respond to operation happenings that may require our support. So if you now look at the disciplines, the courses we studied in school, and the discipline you might be working with, you might be working in the industry. I have a list of common engineering design discipline we have in the oil and gas industry. We have the process. This is purely chemical engineering. Nothing is very exclusive. Mechanical is mechanical. Piping is mechanical. It's wrong piping engineer. Pipeline is not, it's the discipline is not very clear, but we can see that it sounds close to piping and mechanical. But however, the traditional pipeline engineers, those that did the old pipeline, about 30, 40 years, were structural engineers. But in the last 15, 20 years, that trend has changed because of the natural affiliation between mechanical and pipeline. For a pipeline person, you'll be talking about stress. Mechanical people are very comfortable with stress, materials, specification. Mechanical people are very comfortable with material hydraulics. Then you understand what I'm saying? So because of that, the trend has changed. People that now do pipeline are mostly mechanical engineers. The instrumentation is purely electrical related, or for people that were opportunity to do this instrumentation courses in school. Electrical is electrical, civil structure, civil. Marine is marine engineering falls between mechanical, civil. People that have come across in the industry. A lot of them have mechanical background, and some of them have civil background. Same thing with civil architecture. Geotech is geotechnical, and this is some aspect of it is an aspect of civil engineering that covers geotechnical engineering. So where you don't get somebody that has a pure geotechnical experience, civil engineer can manage to function. The industry, like I said before, the industry we work in, the various industries, they have standard guide that you follow, that layer upon your raw engineering training you have in the university. So you can't just do it anyhow. There are standards. We are trying to assess the stress in the pipeline. There's a code that says it must not go beyond this level. We are operating this way. We are operating this way. So all this will come into play to guide you. However, it does not eliminate the fact that you need to be your background engineering training, like the calculations, your stress, how to assess stress, combine stress, all those kind of GDPR is a prominent. Then for the industry standard, you have the ASME, API, ISO, ACS, Hello.
Hello.
Yeah, sorry. I think I lost connection, right?
Yeah, I think so as well.
Okay. Sorry. So I said companies that are very big over time, they have their own established requirement that complements the regulatory and industry standard. The common software that if you want to be doing engineering design that you come across in the field, depending on your discipline, ICs, Pipe Sim, Olga, Caesar, AutoPipe, Abacus, ANSYS, depending on the various disciplines. So then okay, so let me quickly just talk about these last two because I think my time is almost up. And so for pipeline engineering design, so let me talk about 12, then I'll go back to 11. For pipeline design, like I said, you are coming in at a point where it's been fully established that okay, so depending on the pipeline. So for me, I've been involved in the in the pipelines from the wells that goes to production facility where you process. So I've been more involved in pipeline that convey fuel well stream. Fuel well stream, I mean product that is coming directly from the wells. That's coming directly from the well. So it's a different ball game if you are designing pipeline that is carrying refined products within the city. So for us, we are coming in at a stage where business decision has been made. I want to produce this well. It's a project team is set up. Team is just to for whatever facilities provide the well, it will be processed. Where it will be processed into water will be separated, gas will be separated, and the crude will be collected for onward transitioning to whatever is going. And my experience has been offshore, not deep offshore, shallow water, just in the offshore Nigeria offshore environment. There are classes. Maybe by the time we get into pipeline, purely pipeline discussions, we can talk about that. So there's deep water, there's shallow water, and then we have the creek where it's commonly in Nigeria. Those are very common in delta states, delta state and rivers, where we have shallow water. That is the production environment that is common within Akwa Ibom. So where you have shallow water, not very far from the shoreline, maybe some 50, 60, 100 kilometers from the shoreline. That is where you have where the water depth is in the range of 5 meters to about 40, 50 meters. So that's been my experience. So in this field, there are some design guidelines that you follow. But typically, if you want to design pipeline, as part of the business decision, they will have some those guys that participated in the business decision, the engineers that represent engineering or engineering team one way or the other, they will have agreed on the down flow assurance to size the line. So when after the line is sized, then it is now left for you to do as a pipeline engineer to do hydraulics and flow assurance. You understand? So just to be sure that okay, can this typically they go through natural flow from the pressure of the reservoir. You don't put a pump offshore typically. So from well, we are getting fluid from well. So you now want to be able to say, okay, can this product flow here without having forming hydrates in the line, forming wax, all those, then you get the input parameters, flow rates, pressure, fluid characteristics, all this, that, and that is where you use your OGA, ICs, as the case may be, to do. Then the other important thing is your route. You need to be able to, because pipeline is a continuous string of pipe that can span as long as 30 meters, 50 meters. Sorry, I said 50 meters, 50 kilometers, 70 kilometers, 100 kilometers. Then you need to be able to say, okay, I can string this 70-kilometer length. You can imagine 70 kilometers is quite long. 70 kilometers, if you put it in pure context, from let's say from CMS to Ekpe, that is about 70 kilometers. Some pipelines are that long, so you want to be sure that you can have this line. It's a major assessment that you do here. In this, you do survey, you can use the GIS, Then after you do your desktop to fine tune your route, then you now do geotechnical geophysical survey. So what do you do here is along the line of the pipeline, you pick up soil samples to some certain depth that is agreed. You go analyze them to know the characteristics of the soil. Depending on the size of the pipeline, they can be very heavy. Pipe sizes can vary from typical offshore pipeline, maybe some gas lines can be as low as 4-inch, but typically you are looking at 6-inch size in diameter up to like 36, 42, as the case may be. So you can imagine when that pipeline is filled with water or filled with product, 100%, you can imagine the weight. So you need to understand how they interact with the soil along the route, so to know how, Then after you do that, then you now begin to do advanced sizing of your pipeline, the thickness that will be able to contain the pressure and withstand the stresses that the pipeline would see, how stable it will be, with this offshore pipeline, imagine something that is just able to sit on the seabed, and you want it to be you don't want it to float during the service life. So from the beginning, you are making sure the pipeline is stable. Okay, 3 minutes. Okay, it's stable all through its operating life. That's part of what you do as the pipeline design. Make sure you put concrete coating, then you begin to see how you want to bend to navigate the route, the bends you introduce, and as you're introducing the bend, it's impacting the hydraulics. For some pipelines that sees cyclic loading a lot, you want to do fatigue assessment. Especially when you begin to come out from the water to interface with the topside equipment. So we do fatigue there. You do material specification. Line pipe material is a major big deal in the oil and gas, in the pipeline engineering, in general project, general oil and gas project business, because there are few selected. So there's an aspect of pipeline engineering that goes in depth into material, and as a pipeline engineer, you need to be able to, especially if you want to begin to grow to lead pipeline team, you need to demonstrate a lot of competence in that aspect. Line pipe production is a very classical, business. Not anybody can produce line pipe. There are some selected, what do we call them, pipe mills in the world that produce them. Imagine in Nigeria, I think there's a mill in Abuja that can do some form of pipeline, and that type of pipeline the mill can produce is not the one you want to use for oil and gas. For high pressure operation or even typical oil and gas application. Probably they are best used for water, So you need to be able to know the industry, the mills that produce these line pipes. Understand the specification, limitation of these mills, and the kind of quality you get from them. And typically, depending on the quantity, the length which drives the quantity of line pipe you need, it can take up to 12 months, 18 months to produce. And which means you're going to lock down a particular mill for that period. You can imagine, the demand, and these mills are not too many in the whole world, and all the countries, all the oil producing countries, even the non-oil producing countries that are just needing the pipeline for gas transport also depend on this mill. So that aspect of pipeline engineering is very interesting one that requires, you to have demonstrate a lot of knowledge and capability. Then you do your drawings. There are specific drawings. Pipeline drawing and piping drawing are not the same. Process drawings and our drawing are not the same. Everybody has their own areas, Then as a pipeline person, you need to be able to support construction and installation extensively, because as they're putting the scope of work together for installation and construction, you are the first person that will write the draft. Then the construction guys will use their construction experience. Okay, so yeah, I think I've been able to provide some insights, and yeah, it's been a pleasure trying to share the little I know about engineering design. It will be a pleasure again to come and speak maybe in depth about some other aspect of engineering, because personally I've functioned as a person coordinating an engineering team, so managing structural pipeline engineering process. So that requires another level of skill set that maybe we can share with ourselves sometime later. Okay, thank you, moderator. Let me stop at this point in time for others to come in.
Jazakumullah Khairan for the detailed explanation on this pipeline design. Even like going through some of this slide, I can see that some of these items are somehow new to me and is really eye-opening. And so, but if I would just like to like you make mention of in terms of the routing, the standard and the stability. So for me, like if you are to consider the route, like and when you have to consider the route, you have to consider the different in terms of salinity, in terms of the soil. How do you ensure, or how do you like select the types of like piping that is applicable in terms of the ASME, like the piping, like the code that is applicable, and how do you ensure stability in terms of the integrity and safety of this? How do you able to manage all these critical situations together when you are into this kind of design?
Okay, so uh, so you are already talking about onshore. So from the sense, I could sense some onshore questions in your question. That is with respect to soil salinity, where the soil is covering the pipe, and you want to know how that corrosivity of the soil will affect the pipeline. I could sense offshore question when you talk about stars. So when we talk about stability, we're talking about purely offshore, where a pipeline has to sit on the bottom of water all through its service life. So you want it to be stable. You want a stable pipeline is pipeline that is not affected by movement of water. So because it can break the pipeline if the pipeline continues to move back and forth. So you want it to be stable, rigid. I mean, not rigid in sense, but stable and stay at a single position. If it's going to move, maybe do a little movement in 1 year, 2 years, very small movement. So with respect to salinity, yes, there's a standard coating that we apply, and that's another aspect of pipeline materials management. So we have the coating expert that specify that for these soil characteristics, this is the coating you apply it. So then on top of that, we have CP system. It's called cathodic protection system that is applied. So all these are, driven by the pipeline engineer managing its material resources person and the corrosion person. So all these are put in place. So then in terms of code and standard, they are pretty straightforward. For onshore, offshore, typically we use a beta 1.4, beta 1.8. 1.4 is for liquid lines, that is for pure crude. 1.8 is for gas, and they are applicable for onshore. If you begin to talk purely offshore, that's when you begin to talk about DMV, FS 101. So yeah, I think that is in terms of material spec too. We have a specific standard API 5L that talks about the spec of pipeline. The way they probably the way line pipe are manufactured also is another interesting aspect of the pipeline engineering design business. So, and that API specifies, after selecting your line pipe, it tells you how it is manufactured. You now look for the pipe manufacturers that are able to provide to produce pipe to that your spec as per API 5L. So all these are things that are interwoven here. I think I've been able to maybe not 100%, but answer some of the questions you answered, you asked.
Yeah, sure. Jazakumullah. Yeah, Jazakumullah Khairan. And so maybe the participant is going to ask a question at the end of this section. So, but for now, we're going to switch to the next facilitator. So, which is going to be Sister Adebukola Moili. So, she's going to be taking us through the construction, civil engineering, and consulting. So, Sister Moili, over to you, ma'am.
Okay, Jazakallah khairan. Thank you, my dear brother. Let me share my screen. Okay, Assalamu alaikum warahmatullahi wabarakatuh.
Wa
It's
alaikum
been
salam wa rahmatullahi wa
a
barakatuh.
pleasure here, and thank you for inviting and reminding me. I hope I'll be able to do justice to this particular topic. I'll be running through, telling you a bit of the organization I work for, so that you have an idea of what the expectations are in the civil engineering industry. I will discuss a career in Europe, which will also lead us to other opportunities and expectation in the built industry. Then we have the Q&A. Sorry, I have other opportunities. So I work for Arop, which was founded by our founder, Sir Oberop and Partners, based on the philosophy of total design. And total, what this implies is that as a civil engineer, we are the custodian of civilization. If we don't move first, nobody can move. And then, like the earlier speaker have said about so many things, it evolves about the civil engineer. It talks about foundation. It talks about the seabed support and everything. Everything he has spoken about, it involves the earlier starts of the civil engineer in terms of doing the geotechnical investigation, doing the structural design to support everything, all aspects of life. So his philosophy then was that as civil engineers, we should look at the concept of total design. Everything about existence, we should look at it as a whole. So even if the architects sometimes send you design, you can review and tell them that, sorry, this cannot work, it can't be supported. So it also translates to, the total design also translates to our commitment to humanity and sustainability. So this is just an extract of his key speech, and we are a global consulting firm in engineering design. We do technical consulting and advisory service. So we are present in about 34 countries, and our scope of work covers commercial, airports, sports, and so many other things. We also do oil and gas, like he has rightly mentioned. So we've been present in Nigeria since 1951, and we are ISO certified. We are ISO 9001 2015 certified, which I am equally a lead auditor, like he has mentioned. I'm a lead auditor in ISO 9001 2015 and ISO 14001 2015 for environmental management. So these are some of the projects that we have done. We cover civil infrastructure, which basically covers your road, bridges, drain, and everything external to the building. We do that. We do the structural design itself in all sectors: aviation, oil and gas, geotechnique, administration, and project management. So this is an overview of our scope. Now, civil engineering has a lot of aspects. One of which, on a broader view, you see projects and program development, contract documentation. What that means is from the onset, you can have like the design phases are in scheme. Scheme implies that you have an idea, this is what we want to do. You engage consultants and we all give you an idea of, okay, this is a high level indicative cost of what you want to do. We can decide to go and price it also and see, is it within budget? Yes, should I go for it? So all those are within contract documentation for us to check the viability. Then we can now go into project management and development. All these are still within the role of the civil engineer before we proceed to design management and contract and construction management, which means that after the design of everything you want to do, we can now manage our own design to your expectation, which is also the role of the civil engineer. So I'm going to focus more as a consultant because we don't do construction, but we do construction management. But if you have questions on construction management, you can ask me, because I've also been involved in series of construction. So part of what I've been opportune to do as a civil engineer is urban planning and regeneration. For some of us that are familiar with Ikoyi, you will notice some roads that are ongoing. It's one of the projects I'm on. The Lekki-Epe Expressway from law school all the way to Plaza 2 and beyond. It's part of the project that I've been involved with as a civil engineer, but I was sitting on the seat of the independent engineer as an arbitrator, as either, I was sitting as an arbitrator between government, Lagos State government, and the Lekki concession, because it was a concession road, and that's why you're seeing tolls along the line. So what we do is we review the contracts and advise both the concessionaire and the government that, okay, this is okay, this design is okay, the alternative route is okay. We check the pavement design, we check the drainage design, we check the speed, we evaluate the safety report. So during the period we're on the project, we receive how many accidents, what is the cause, go and investigate what is the reason behind it, the speed limits, and everything about the project. So one of the things we want to emphasize is when I decided to move to my present company, I was working in a private firm also. As the most senior civil engineer in the firm, I was next to my boss. And at that time, my boss felt I should take over the company because, alhamdulillah, I was doing well. I was delivering everything, admin, design, meeting clients at high level. Then it was during the regime of Fashola. We go to Marina, present our project. Bagada, the concrete road in Bagada, General Hospital, and last week was one of our projects then, and I was leading it amongst other projects we were doing. But at that time, I felt I need to do more, and that our projects are government regime based, because we're also working in Ogara with the Delta State government. So I felt that most of our projects are government based. And what happens if there is a change in administration? So I had to move after my master's. And alhamdulillah, my boss is a very supportive and understandable boss. He supported me because of my commitment and the willingness to give as much as I can within my capacity. So I was working full time, and I was equally working. So all this, I must be honest, I was mentally unstable. And he also understand and was surprised that I opted for that option. So what I'm trying to emphasize is that commitment is important and we should be open to opportunity. Like the moderator introduced me, my master's is in civil engineering, structures option. But where I was working before, we have a lot of civil infrastructure projects, road design, community development, sand filling, doing platform level and all that. Sorry, platform level is okay, we need to fill, we need to cut. I will still get to that. So he would teach me like a young engineer. That's why my experience then. So I was very open. I was very, very open to, oh, sorry, someone reported that my audio is. Please, can you all hear me now? Okay.
Yes, we can hear you.
Yes, I was very open to learn new things, and that changed my area of specialty from core structures to also give me the opportunity to be doing civil infrastructure. And when I went back to validate my acceptance of our offer, I also told them that aside my knowledge of structures, I can also give this support for civil infrastructure, and that was a plus for me. So looking at the indicative cost of what AROP offers under these 4 major headings, and we have broken it down, I've virtually, like every other engineer in the organization, been able to go through virtually everything, both in Nigeria and other West African countries that have been opportune to work in. So what are the key requirements that you ideally will see that we will tell you that we're looking for? As an engineer, we need your knowledge of engineering design. I don't want to say structural, but engineering design. Because at some point, I've also led a multidisciplinary project in Shell. And that means I had to understand a bit of mechanical, electrical, safety, project management, structures, geotech, all in all. But all this you're going to acquire as time goes on. It's not something you read in the book, but as you work. So these are some of the diversity we have in terms of resources. But because of maybe my level of experience, I've worked with virtually all of them. All of the present level are now occupied. So, but for some of us that were just coming up, there are various aspects in civil engineering. There's structural design, there's carbon management, there's building, sustainability consulting, civil infrastructure management, project management, a whole lot of them that I have listed. So one of the key things, like my brother was mentioning in his earlier presentation, he mentioned so many things, but you have to now narrow down into what exactly do you want to do. So for me, I now focus more on civil infrastructure design, project management, quality management, and management at all level. And under technical, I do more of civil infrastructure design. That means I do road design, I do pavement design, I do drainage design, and I support structural team that do brick design. I don't do brick design. Then now I have new area of focus, which is sustainability consulting. We're presently evaluating, one of my projects is the evaluation of the solar power deployed to some government parastatal in Lagos, which we are aiming to achieve a net zero to help Lagos State improve on power supply. So it was not something that I learned in school, but it's something out of what can be done better for the citizen. I mean, for humanity. What more can I learn? What can I do differently? Everybody is doing structural design. Mama, everybody is doing structural design. Everybody is doing many things. What can I do differently? So then I also look at the organization. What are the opportunities that are open for me there? So as a global firm, I had to do a bit of research. So what that implies is that for you, if you are seeking employment, what are your targeted industries? Oil and gas, what do you need to know? Okay, people go onshore, offshore. Like for us, we work offshore. Those are the supporting facility. But some of my team work onshore. They go across to the platform and all that. But for me, I did a SWOT analysis. How do I get into this discipline, the oil and gas, and be able to support? So part of what we do is we support the facility that are offshore. We have done projects in Sapele, the open gas plant, and so many other things. So in terms, when you mention pipeline support, we do the design of those pipeline, their compressor, there are so many other things that are outside there. But I'm not present in the core industry, but my structural knowledge is not applicable in these aspects, then my civil infrastructural knowledge and every other knowledge of managing various teams, getting the equipment loading, interacting with various disciplines and what their expectations are. So I just listed a few of some of those structural software. Autodesk AutoCAD is a must for all engineers. They will now narrow down into other software like Start Pro, Revit. Like in my organization now, Revit is almost a must for everybody. Then so many other ones that are available for you to use for structural design. Then for me, for some of the things that I'm doing in sustainability consulting and carbon management, we do modeling with Excel, we do questionnaire. So sometimes when you see the broad term, interpersonal and communication skill, it's all encompassing. You should be able to know, how do I manage to get information to model what I need? So it might be in form of questionnaire, it might be in form of phone calls, it might be in form of emails. So as an engineer, it doesn't mean that you don't need all this. Then your network also matters. Your network in terms of who are the audience that you can actually get immediately now. That's why our affiliation to professional bodies is important, because sometimes when you just send an open questionnaire, you might not get response, but when you send it to the right audience, you're able to deduct that, okay, this is important. Then people will respond. Then for bridge also, we use Ashton for the design. There you'll be able to see HA loading, HB loading, dead load, permanent loading. That's why on the bridge you see that sometimes when they want to do repair, they have to remove the asphalt on the bridge because you have permanent dead load. Then if you now want to add additional, like the resurfacing, it's going to create additional dead load, which the support, like the other members, the beams, the pier, the pile cap, they are not designed for. So the opportunities that our recruitment strategy is through network. Like for me, after I applied to AROP, I met my chairman at a professional event, and I told him that, oh, really, you are the chairman? Okay. Sorry, he wasn't the chairman then, but he was one of the directors, and I told him that I applied, and he said, okay, they have a process. So my offer came 2 years after. Then you can also submit directly to AROP. And these are the key things we look out for: excellent academic record, experience, creativity, and a whole lot of others. Then another thing that we want to emphasize is that sometimes you can approach recruiters and they will be able to penetrate for you. So if you have the network of recruiters, please leverage on it. It doesn't have to be AROP. I mean, there are so many other not as big organizations that are doing well in the engineering industry, but it's very important that you have a career strategy and how you want to go about it. Then I will also emphasize that your online presence is very important. The way you post attracts the kind of audience you want. So if you are focusing on infrastructure design in oil and gas, I'm sure you get people inviting you to come and talk about what you've been talking about. So whatever you want, you strategize to attract it. And another thing is volunteering, like what we're doing today. Some of us are planning to give back to on our experience, sharing with you what we've been able to build over the years and how you can go about it. So I encourage us to volunteer, because during the course of volunteering, where those opportunities I have to network with people of like minds, to do things that are not co-engineering, like sustainability that I'm doing now, is because I volunteer in doing some of these things that are outside my core area. So I also want to share this. This is a recent offer that came to me, that as a project manager, the person tried to connect with me, but I didn't accept. And she had to now go through like 3 other recruiters that she thinks I perfectly fit the role. But because I have my career strategy, the way I want to move, how long I want to stay in a particular place, I have to now connect with her and now start looking for opportunities for others, most especially our brethren like you, to fit into this. So what do they want? These are the things they are looking at for. So you can see the job, the job seniority is a manager, the job category is in management. So you have to be intentional about your career growth. How do you want to go about it? Where do you want to be in 5 years? Where do you want to be in 10 years? Where do you want to be in 15 years? So for now, when I look at this, it's something that I would really have gone into. Like many other opportunities I've had, friends that are relocating that want a post to be filled, it has housing opportunity, car, and all that. I might not get that in my present employment, but I think career fulfillment is also important. So this is still open. If you think you fit in or you think we can talk about it, how we can get here. This is an opportunity that came my way, and I think I should also share with my friends. So I will round up with that to say I wish us the very best, and may Allah use our affairs and make us steadfast and make us a benefit to the woman.
Yeah, Jazakumullah khairan. Like we really appreciate this. Like it's so encompassing, but when you look at it, especially like as a lady in a kind of career that is actually dominated by men. So how do you feel sometimes, like considering your gender, like how do you try to manage around it? And so what is your advice? Your advice for someone who is not civil background, and how can they like navigate in a civil environment?
Okay, well, navigating in the civil environment, I deliberately put this picture, for instance. You can see that as at of the last analysis we did, we're at maybe ratio 90 to 10. And initially, I used to feel intimidated, especially when I was in my formal place of work. I would have done the whole work. And for me, when I need to now meet clients, the person will keep telling me, I'm looking for engineer Nimot. I'm looking for engineer Nimot. You see the expression that, no, you shouldn't be a female. So as a female, I think one thing is important. You should be able to motivate yourself that you can do it. Don't get intimidated. Then choose, like I rightly mentioned, choose your career path. I deliberately left the construction industry because one, I can't mortgage my time to stay late in the night. I can't mortgage family time. I can't mortgage my health. But some of my mentees that are in construction now, they work and sleep on site. I can't cope with that. So I took that decision early enough to cope with a small salary and grow. So for some that opted for the big salary, they're virtually on the same scale now. Some of them are director in government and also equally on the managerial role. So it's important that you work at your own pace. Choose your career path, which one works for you and for your life. So for me, consulting worked for me, and that's why I'm choosing it. You can go into the oil and gas industry and just you can decide to do maybe like quality management. One of the projects I did in Liberia is quality management. I was the quality engineer for the whole project. One is a managerial role. At the time, I was not a manager. And I just feel, okay, this will give me this opportunity. So I started doing it. So I think it's important that you understand what works for you and don't feel intimidated. Know your onions and be on point at all times.
Jazakumullah khairan. So if any other member will going to have question, that will be at the end of the section. But now we move to our last facilitator, Brother Cousin Abdullah. And so I introduced him earlier. He works in G Power. So Brother Cousin, over to you.
Yeah, Assalamu alaikum, brothers. Can you hear me?
Yeah, we can hear you. Wa alaikum salam.
Yeah, so thank you very much, Mashu, for this opportunity to have an audience in this forum. I'm really excited. I'm really happy with this kind of engagement. So basically, I didn't want to ponder too much about what I do and what I have some level of knowledge. I I've been working in the power generation industry for some time now, and I have been forming part of the teams that review and analyze the power generation issues in Nigeria, and also having hand information through engagement with the most of the gencos around the country. So generally, I don't have much to present, and I don't know how much time I have, but I wanted to make this a kind of interactive session so that people can also chip in their own contributions, and maybe if you feel that you want to ask question, you can stop me at any point. So everyone that lives in Nigeria or in most of the African countries, we all know the challenges with the power, and there's no any doubt about the fact that power is the backbone of economy. Power is the spinal cord of development. If you don't have power in your country, you cannot grow economically. You cannot develop in terms of getting some more infrastructures and additional development. So there's a very large vacuum in between the demand and supply of power generation in Nigeria. We all know that hardly you can see anywhere around Nigeria where they get 24 hours of power generation. Is not really very common. Yes, there are some privileged communities, more especially those that are located within where we have this power generation companies, where they are privileged to get maybe 20, 22 to 24 hours of electricity. But in general, if you look at the maybe 90% of the Nigerian populace, nowhere that you can see power being very stable at the rate of 247. So there are huge opportunities for everyone, more especially the engineering folks. There are a lot to be done. The Nigerian government has been trying to invest in the power generation for some time now, but because of the peculiar attitude of our leaders in Africa, corruption and other things, is not making us to see a very good result in terms of what we are investing, right? Can you guys hear me? I don't know if I'm speaking to myself.
Yeah, no, we can hear you.
Yeah. So yeah. So if you look at the kilowatt per capita, which is like a measure of the average kilowatt hour of electricity generated per person in a particular country. If you look at Nigeria, you will see that we are currently, like the last data we got, which is around 2015, 2016, Nigeria is at 145 kilowatts per capita. And if you compare this with some other developed nations like maybe South Africa, for instance, which is also part of Africa, South Africa has a power kilowatt per capita of about 4,190 or thereabout. So if you look at the population of South Africa, which is way less than maybe 25% of the population of Nigeria, but then if you look at their generation capacity, is like almost 10 times that of Nigeria, because South Africa now they are generating up to about 40,000 megawatt of power. So these are some of the numerics, these are some of the facts that you should always be, as engineering folks, we should always look at, okay, so these are opportunities, right? If in a country with a population of almost 200 million people, generation capacity of less than 7,000. So you could see a lot of potentials, right? A lot of opportunities. If you take other countries like Ghana, Ghana is even per capita wise, or kilowatt per capita wise, Ghana is around 350 kilowatts per capita, which is like twice the generation capacity of Nigeria, right? Twice the 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 um, the average kilowatt hour available for their citizens. So these are some of the things. These are some of the key issues. But then, if you look at from the government side, the question is that, do we have all the better pieces of the power jigsaw puzzles? Yes, you can say yes. We have them. We have the power plants. We have the national grid. We have installed capacity of about 10 gigawatt, which is about 10,000 megawatt. But then, are these pieces working together? No, because if you, my experience and my exposure with most of these power generation companies, like SPDC, for instance, which has installed capacity of 650 megawatt, a power plant in Afam. But if you happen to visit that power plant at the time, you discover that they are running at maybe less than 50% of their generation capacity. So their situation is like a stranded power. They have the power, it's available, but there's no evacuation. So the key issues with the Nigerian power is more or less around the transmission capacity, right? We have the transmission line, we have the national grid, but how often did the government invested in expansion of this grid? In other developed countries, we have what we call the smart grid. Smart grid is not different from what we all know. All the smart technologies that we have, smartphones, smartwatch, smart TV. These are, the same characteristics that the grid should have. What we have now is a grid that has only one way communication in terms of delivery of power. It's generated from the GENCOs, transmitted to the consumers, and there's no feedback. But in the smart grid network, it's from a kind of a two-way communication that, okay, if for instance I'm a consumer, and then maybe that's the grid will be able to respond to my demand in terms of whether it is the peak hour, when is the electricity cheap, when is the tariff. So it has this kind of fluctuation in terms of even the cost of the power. But so unfortunate for the African countries, Nigeria, which is one of them, we have serious challenges in this. So this is what I want everyone on this forum to start thinking about. These are the challenges, these are the issues. You don't need to be an electrical engineer to see or to contribute your own part in trying to resolve the power issues in Nigeria. You don't need to be a mechanical engineer. As far as you are an engineer, you can have a sense of problem solving, capability. So these are some of the challenges, right? And again, if you look at what the government presently is doing in Nigeria, trying to see how they can review the tariff. The last one was reviewed in 2015, but this is not really has the potential of attracting investors in the country. So now the government is saying, okay, one of the key fundamental issues is our electricity tariff, right? If now we are selling out to the consumers at the rate of maybe 27 naira per unit, how do we increase the tariff to make it a bit more competitive, to make it more attractive to the investors? So that's the recent power tariff review, which was just postponed by the government, right? They intended to implement it, I think, last month or early in July, but now it was pushed to some other time due to COVID. So what they are trying to do here is like, let's see if we can make this power generation a bit more attractive to investors, because I can tell you about 80 to 90% of the power generation companies that we have in Nigeria, they are not making profits. And why? Because of the stranded nature of transmission system that we have in Nigeria. So at the end of the day, government is bailing them out through embed, through other programs, trying to see how they can support them. So then if we are in a country where every investor will come in, invest a lot of billions of the dollars to build a power plant, and then they have to rely on the government incentive. So at the end of the day, it's not going to be a win-win situation, right? It will be like, and it creates avenue for corruption, because if government will be the one that will be giving out incentives to the power generation companies, it will be just like the fuel subsidy regime that we experienced in Nigeria, and it will be very difficult to come out of it, because um, a lot of people are benefiting from that. So these are some of the things that we as engineers, we look at the bigger picture of, okay, these are the problems, right? So what are the solutions? So I want us to start thinking of some other form of power generation solutions that we have. The renewable power generation, there is a lot of opportunities in there. If you look at the solar, for instance, our solar investment in Nigeria is way less than 30%. If you go around maybe your community, you go around your area, how many people do you see having this solar plant or solar connectivity in their homes? But if you go to countries like Germany, go to countries in Europe, a lot of the countries in Europe, they are moving away from the conventional power generation, even though it's available, right? It's so available, it's a bit cheaper. But then they go for these alternative or renewable energy sources because they have what we call the smart grid also available for it. So if you are generating in excess, you can also transmit it back onto the network and gain some money out of it. So look at this as maybe a way out. We have seen a lot of bigger projects in countries like UAE, for instance, where they have this solar thermal power plant in maybe almost one gigawatt solar thermal power plant. We have the sunshine. The sunshine is free. It's a free energy, right? I have solar power in my house, and I have seen the difference, how I really am saving in terms of what I'm getting from the PHCN. So as a young, as maybe engineering entrepreneurs, start thinking about how do we tie up to these opportunities that are out there, right? How do I go for some form of training to understand the basics? Because the guy I brought to my house to install my power, my solar power, I see that he has nothing to do with engineering. He's just a guy that went to learn from another person, and then he didn't even understand the engineering behind it. So, but then if we engineers can own this kind of opportunities, let's say maybe Moshood will have a small company that he's into solar panels, he's into batteries, maybe he's ordering it from Germany, right? A lot of people will say, oh, engineer Moshood, yeah, he's an engineer, we know his product is good, and they can have trust, and then you can improve based on the lapses that you can see in all those kind of businesses. So there are a lot of opportunities out there, right, that we can as engineers contribute. Yeah, in the bigger power pool, the conventional, maybe the power plant, we cannot do do much because at the end of the day, you will not be the owner of the plant. And it's a very huge capex project for you to say, I want to build maybe a 2 megawatt or 1 megawatt power plant. But we can start from the smaller kilowatts of power. I have seen some form of maybe cluster power generation that happens around maybe in markets, some market areas, some estates in Lagos, people providing power generation services. So these are the way to go about, right? Decentralization of our grid is the only way out in this situation because we don't have the right capacity of grid that can handle the demand of power that we have in Nigeria. So having to have maybe some islands of power generations around, it will really help. So how do we tie up to this? How do we start thinking, start aligning with the investors to go into all these kind of business opportunities? You don't need to be, an employee of maybe somebody, but you can be an entrepreneur, you can be an investor, you can be a consultant, right? So these are some of the things that I want us to start thinking. I don't want to talk too much about the problem, but I would rather say some things about how do we come out of this, and how do we take advantage as engineers of the problems, because we are problem solvers. So I will not say I don't have a presentation to make, but I think I've said maybe some few things that if you feel free to. I want it to be very interactive, right? Moshood is very experienced in the power generation. He has been supporting us in so many issues with our customers, right? So, but I want everyone on this forum to start thinking of how do I be part of these solution providers, right? All right, I'll pause here. Thank you, guys.
Yeah, Jazakumullah khairan for that topic. And we have so many questions like online though, but like, so if I just have to like a recap, like you make so mention of so many issues, like, and what are the things we can do? Like you talk about like, okay, decentralized power is like the way forward if you have to consider the current Nigerian situation. So like maybe you can shed more light on the centralization for so many people that might not be able to understand that. So I can just say, like, you generate power in a particular location and then you distribute it to that particular location. Unlike the current one we are having in Nigeria, that you all put everything to the grid. That is one of the reasons we having issue with the power issue or the power situation in the country. And also, you made mention of the renewables. So, but my question would have been, like, how sustainable is this renewable power is going to be as compared to the conventional power system that we have? So maybe you can just like give a kind of insight on how the sustainability of the renewable as compared to conventional power, like hydro or like the gas turbine or other kind of conventional power systems.
Yeah, thank you very much, Mashud. Right. One thing that is very important to know is that the renewable power solutions is not a replacement for the conventional power solution. The conventional power solutions are the basics, right? So you need to be strong on that. If you look at countries like Germany, countries like Canada that has almost 15,500 kilowatt per capita, you will see that their generation capacity is like almost 70 to 80% still conventional power generation solutions. So, but then the renewable power solutions are a bit expensive, right? And the stability in terms of comparing with the conventional means of power generation is less. Like for instance, if you have a solar power plant in your home, you may not be able to get 24 hours of power without investing more into maybe storage capacity, right? So if you look at the just a typical solar power plant that we have in our homes, if you do the critical path analysis on that and see which one is the highest in terms of capex, you will see that is the batteries, right? So this is the reason why even in developed countries like Dubai, UAE, where they have the largest solar thermal power plants, they don't go into very large capacity storage of power, right? Because for solar power, for wind, for geothermal, they are all dependent on so many factors. And some of those factors that we don't have control on, like the solar, for instance, it depends on the sunshine. We don't have control over the sunshine, right? Like the wind, we don't have control. So we don't have control over the geothermal because it is generation from the heat in the earth crust. We don't have, so a lot of all these technologies, they are not actually to be a replacement for the conventional power generation solutions, but they are complementary to that, right? If you look at countries like Algeria, for instance, they have a smart grid solution. If you look at countries like Netherlands, Germany, they have smart grid solutions. So what they do in those kind of settings, they have a lot of this conventional power, and then they have the renewable power plants tie up to the same grid. So what happens if in the daytime, when there is sunshine or when the wind is having the right velocity to drive the wind turbines, the smart grid will be able to send a signal to the conventional power plants to go down on their generation, right? So that's why I said the smart grid is really a key in all this integration of the renewable and non-renewable, conventional and non-conventional power generation system. So the answer to that in general or in one line, a renewable power solution is not an absolute replacement for the conventional power solution. I don't know if this answered the question.
Yeah, Jazakumullah khairan. And we have a brother that is raising us, so brother Moshood Sanusi. So I think he wants to contribute or ask a question. So over to you, brother Moshood Sanusi. Hello, are you on mute? I think the brother is on mute, maybe whenever he's available. So, but as we can, we have a question like from someone on the, he was asking like, why haven't there been attempts to explore ad hoc means of power generation, such as power generation vessel, like we have in other West African countries? So what answer would you give to that?
Yeah, I think I said this at some point, Moshood, right? If we look at the power issues in Nigeria, I see it like a jigsaw puzzle, right? In a jigsaw puzzle, you have a lot of pieces that you need to piece together. And sorry, is somebody speaking?
If you are, can you be on mute, please? Okay, so you can go.
Can you hear me?
Yeah, we can.
So what I was trying to say, right? If you look at the power issues in Nigeria, I see it like a puzzle, right? And if you know what a jigsaw puzzle is, you need a lot of pieces to piece them together to get the right shape of what you want to achieve. So if you look at the issues of power in Nigeria, there are so many pieces that you need to piece them together. But we have those pieces, but they are not pieced together. They are not brought together to form the solution. So now, if you're talking about ad hoc power solutions, like yes, but those are nice to have, right? If you ask any expert in the power generation business, he will tell you that we need to get it right on the conventional power solutions. We need to get it right on the steam turbines. How many steam turbines power plants we have in Nigeria? I have visited one of the largest nuclear power plant in Switzerland, which is generating 1,000 megawatt, just a single power plant. And it's a steam turbine, nuclear power. So how many steam turbine active power plants we have in Nigeria? But we have a lot of the resources. We have water everywhere. We have the land. We have everything to do that. So, but we are more focused on projects that people will get money in terms of procurement, whether they will work or not. Moshood can testify to that. We have a new fast power project ongoing in Port Harcourt, which is owned by the Ministry of Power, installing about 8 TMs, these aeroderivative gas turbines, which is each one is about 25 megawatts. So if you look at that kind of investment, why do you do such investment in a country where you have a lot of issues with your conventional power generation system? These are peakers. These are just to augment what you have if you already have it. Let's say you have a generation capacity of, let's say, 10,000 megawatts, then maybe at peak hours, you need 11,000. So you install these smaller units just to augment. These are the ad hoc power plants. You install them to augment the 1,000 megawatts so that maybe at the peak, at the off-peak hours, maybe 5 p.m. when people have closed from their businesses, you don't need much power on the grid. You can shut them down because they are quick peakers. They can easily start and easily shut down. But you can't do that on steam turbine. For you to prepare the steam to start a 1,000 megawatt steam power plant, it will take you more than 3 to 4 days to generate the right steam quantity, quality and quantity. So you can't just shut it down because you want to reduce 1,000. So you need to have this ad hoc. So the bottom line is you only have this ad hoc and nice to have power plants or power solutions when you have overcome the basic power requirements. So that's my answer to that.
Yeah, Jazakumullah khairan. So thank you very much for this. And we're going to move to the question and answer section. And so to start with, I think I will be starting with Brother Shamsuddin Sadiq. So Brother Shamsuddin, since the fact that you deal with so many people on site and you understand the importance of the technical knowledge of engineering, like having the kind of analytical skill, the observational skill, having like the physical theory, the stress of material and everything. So which one would you consider, like over the years of working, like which would you consider like a kind of greatest asset for you in terms of either technical know-how or effective communication in this regard? So which would you rather think of if you have to like give an advice for someone in the field or someone coming into the field? Would you rather like, okay, pick the technical know-how over effective communication, or how do you balance the two?
Yes, Assalamu alaikum warahmatullahi wabarakatuh.
Wa alaikum salam wa rahmatullah.
Yeah. So it depends actually. Okay, where I work, because of the size of the organization, you need people that will do management, and you need people that will be doing the field work. So when I say field work, I don't necessarily mean people that go out there and start cutting steel or lifting items. I mean people that manage execution. Over time, it depends on your area of interest anyway. So for people that that have excelled very well in the soft skill area, like the communication, the general broad-based HR soft skills, empathy, this emotional intelligence, and the likes. You see them turning towards management. You get what I'm saying? Management side. Whereas people that focus more strength of technical capability, know-how of how to do, execute things. You see them, occupying the role like construction manager, maintenance manager. You get what I'm saying. So it depends on what is suitable for you and your outlook. If you are the type that that likes to get into to top level management and you want to be on the board, maybe you can begin to work more on your soft skills, how you manage people, how you interact. However, there is a basic expectation of everybody. It's a multidisciplinary environment, multinational environment where you work with various people from all over the world. You are expected to demonstrate some level of tolerance. Beyond that, then it is driven by interest. For me, all the while I've been tending towards the core technical side. So, and also another driver is what the company has as an opportunity for you. If they think there's a gap, they want to fill the management side, and if they assess your capabilities and they think you can do it, you don't have a choice. You get, so that's the way I would like to respond to that. So if you're able to, wherever you find yourself, look at what is available or what is obtainable. In some smaller organization, you need to do the two at about the same level. And in some, they just want you to do your technical job and provide technical support as will be required of you. And then they leverage other people for that soft skill and management. But if you want to if you're hiring to be part of management, it's always very good to balance everything up. You do your technical and the other side, the generic HR soft skills across understanding the general business drivers, interface with the media, HR expectations, human resources expectations, and generally. I hope I've been able to provide some.
Yeah, definitely. Like, so which implies that both skills are actually required. So depending on your focus and your long-term goals.
Yeah.
Okay. Yeah, so my second question will go to Sister Nima. So Sister Nima, so the question will have been around like, okay, how are you able to manage failure? Because like in engineering, like failure is part of what we call the lesson learned. So how are you able to manage some of the failure you've encountered or some of the challenges you've encountered in the field? And how are you able to adapt the solutions to whatever scenario going forward?
Well, I think failure is an opportunity to get better. Looking at it from the engineering point of view, you have a field structure anywhere in the world. I mean, anywhere in Nigeria, you see up to example making comments about it, and that will prevent the next failure. So, like, I would say part of the starting point when I started volunteering in a professional organization, I was going through trials and I needed to get off sleeping pills to maximize my time to be able to sleep naturally. So I had to now look at, okay, I want to volunteer. Where do I volunteer? So I started with Nigerian Society of Engineers, APWEN, and so many other organizations, and locally and internationally. So all the facilitator might have said so many things. It's not a straight line curve. But the thing is that you must also always give yourself the assurance that nothing happens without the knowledge of Allah, and that you're actually not a failure. Just tilting you towards the right direction of, okay, have you checked this? Okay, you didn't succeed here. Why not check this? When I started as a quality auditor, for instance, it was all like, okay, there's no much work in the office. Can you join the team? But it became one of my strengths because I leverage on it. I explore what can I do beyond just auditing. Okay, I can go for international certification. And luckily, Liberia project came and like that. So I think we should just exploit the negative side of whatever comes our way. Let's look at it that the glass is half full rather than it's half full. So that's where I've been able to cope with some of those challenges. It's not going to be a bed of roses, but be ready to make the sacrifice.
Thank you for that. Yeah, so I think that's the necessary advice for every engineers. Like, we should always embrace failure as a kind of opportunity to open other door. So if you've heard about Thomas Edison, I think, like he said, he has not failed, but he has only discovered 10,000 ways in which something will not work. So he sees as a kind of opportunity to actually find different solutions to different situation in the world, and that is why he was able to found one of the greatest company in the world. So the next question will be to Barakazim Abdullah. So there is a question in the Q&A, and so I think he will be answering the two questions at a time. So the first one is, apart from the corruption you mentioned, what are the other major problem in the power sector? And the second question is it possible for a telecom engineer to move into power sector, and how would you encourage such telecom engineer to move into power sector?
Yeah, assalamu alaikum. Thank you, brother Moshood. I think let me start with the second question, right? Yes, telecoms engineers, I think in the power generation business, we call them the I&Cs, right? They are the instrumentation and controls engineer. And I think to transition from telecoms to I&C, is you just need some couple of maybe exposure in terms of trainings. Those are the backbone of our, more especially this smart grid, and the control systems that we use in all the power plants, and also controlling the grid, controlling the you integrate everything through the control system. I think Moshood is one of them. He can say a lot about it. There is a very huge opportunity for the telecoms guys in the power generation business. It's just to have the right level of exposure, maybe, and trainings to be. But yes, we don't have a specific specialty called telecoms in the power generation, because we don't really do communications in terms of maybe the telecommunications, but we do communications between all the pieces that we have in the power plants. We have the Max 6 controllers, we have the Egatro, we have a lot of controllers, right, that integrated the power plant as a whole. And also we communicate with the network, the transmission lines as well. So all this is the same knowledge, is the same basic knowledge of telecommunication. So it's just for you to have the right skill set and also the right trainings and exposure. You can decide to take the path of becoming an I&C specialist, or even a controls. We have what we call control TAs. Those are the technical advisors that we call them control TAs. So those are the guys that interact with all the control system. They interact with all the lines of communications within the power plant. Because I can tell you, if you go to any of the power plants, you will see thousands of cable networking between equipment, between gadgets. You will see a lot of switches. You will see, so a lot of interaction of data is happening within a particular power plant. And we need you guys, we need the telecoms guys, and you can be able to just align with being either a controls or an instrumentation and controls specialist, that you can be able to work in the power plant. I think you can explore that, right? And if you need maybe more details after this, you can talk to myself or talk to Moshood. We will guide you on the right path to take to achieve that. So I think the second question, if I answer this question right, I can go to the second one. So
Definitely.
So apart from corruption, you mentioned what is other major problem in the power sector. I think well, corruption is like a cancer, right? So if you have a cancer in your system, I think you just need to work on that before you can start talking about other, because it can lead to other system failures. So for the power sector in Nigeria, apart from corruption, right, we lack the right policy. When NIPPs were created, it's a very good step. It's a very good initiative by the Obasanjo administration, which they spend almost $16 billion in procurement of power plants. And yeah, it's a very good initiative, right? But they miss the most critical aspect of this power generation, which is the transmission. You can have millions of power stranded in power plants, but if you don't have the network to transmit it, you cannot go anywhere. So I think the right policy from government in terms of where they should focus their investments and where they should focus in terms of upgrading the network is the transmission. So government policy is another key issue that is facing the country in terms of which is the right way to go. The government has made a lot of investment everywhere. They have privatized the discourse, the distribution arm of. So in power generation, we have the generation, transmission, and distribution. So if you don't integrate these three together, you cannot be able to solve the power problem in Nigeria. So government, when they come, they invested a lot in the generation aspect through the NIPP, through some other NDPHC and so many other power plants. So then they also privatize the distribution. They privatize the PHCN into KEDCO, Ikeja distribution, Abuja distribution, which is a good thing, right? But then you cannot move the power from the generation to the distribution without having a transmission network. So they didn't invest so much in the transmission. They didn't upgrade the transmission network. So now it became a bottleneck in the power generation aspect. So, but now the government is working on that. I see a lot of projects. I see a lot of development in that area. But I can tell you the key issue apart from the corruption is the right policy. Where do we invest? What do we privatize? So they didn't get it right. So I don't know if I answered the question.
Yeah, Jazakumullah khairan. So we have a brother Nurain. He's raising his hand, so maybe he has something to contribute to this. So, brother Nurain, the floor is open for you.
Assalamu alaikum.
Wa alaikum salam.
Yeah, say Brother Kazim Abdullah, Jazakallah Karen, speaking on these issues. Speaking on these power generation issues and also speaking to specific problems. So, in line with the reason why this forum was created and the reason why we are on this call is the immediate need and areas where we can tap in and have an effect, to have proper solutions to this identified problem. So from your view and your experience in this field, where would be the immediate area where the Muslim engineers can, tap in and have an immediate solution? Where would you suggest?
Yeah, thank you, my brother. Thank you for that. Well, I think I don't know. I said it at some point in my submissions, and I was saying something about we know the problems, right? They are everywhere. It's the same problem. How do we provide power? How do we generate electricity for our needs? And there are options of some renewable options, which is like the solar, which is the immediate. I see that as an immediate solution that we can all work together and start thinking about how we can integrate this solar power plant into our homes, into our businesses, I was thinking about something like that with one of my colleagues who works in the education sector. And I was telling him that imagine if the state government will say, hey, guys, you young engineers, can you give us a solution on how we can get just a power in the schools during the daytime, just to power the fans, ceiling fans, maybe some electronics, you know? So this is a very simple concept that we all know and it's out there for everyone to leverage on, just to get the power, the solar panels, just to get the maybe the inverters, just to connect it, maybe with one battery or something. So these are the immediate solutions, right? I know some of the people on this call, maybe they have it in their homes. Also the generator aspect of maybe using a diesel generator, using yes, these are some of the solutions that we have seen, but they are not really working, right? Because if you look at the costs for maintaining a let's say 1 megawatt diesel generator that will power a small industry is huge compared to the cost of maybe in terms of the units that they purchase from the gencos, from the discos. So, but then if we can start thinking of how to have a hybrid solution, we just one of my guys just I happened to be part of the team that just went for a visit. There's a power plant that was just built in Kano State University, which is no Bayero University in Kano. It's a 3 megawatt hybrid power plant. It's a hybrid of diesel generators and solar panels, and it's working. And when we interacted with the university VC, I think last month or so, he said they were saving about almost 5 million naira of electricity bill every month. So these are some of the solutions that we, and these are young engineers that work with the REA, Rural Electricity Agency, to come up with a project like that. So you can see now this is the kind of islanding solution that we're talking about. This is the decentralization that we're talking about. If you can have a particular cluster of maybe homes of industries that you can have your own generation network and you can have your own power plant, you don't need to overstretch the existing grid that we have, which lack the capacity to accommodate what we are generating. So the government was also working in that as a very short-term solution. Now they are giving license to GenCos, smaller power generation companies that can go into. I see one in I think is it in Aba or somewhere where they provide power to a market, and I see one in Kano where they are also using solar power plants to provide power solution to a very large market. So these are the immediate solutions that we need to, pending the time that the government will invest heavily in the transmission so that we can have a transmission capacity that can maybe handle the 10,000 megawatt installed capacity of the generation we have. So I see us as engineers aligning with these minds, young talented minds that go into all this research, just a small research and analysis of a particular maybe a cluster where you have houses, where you have industries, know what is their capacity, what is the needed power in terms of capacity, and then think through how you can provide a solution. If it is a daytime business, you have the solar there out there for you to explore. You can guarantee having maybe 6-7 hours of sunshine daily. With that, you can make money, right? Yeah, it's a high capex investment, but I can tell you there are a lot of people out there who are coal investors and they have the money. It's just for you to present the right business proposal for them to invest. So you don't need money to start a business. As an engineer, you need to convince me as an investor that, hey, this is the business proposal, these are the potential, this is the profit, These are the return on investment. People are out there, banks and other financial institutions that are out there for you to invest. So for young engineers, young entrepreneurs, it's not an excuse to say, I don't have money to invest. Just have the idea, right? A workable proposal that is profitable from its content, you will see a lot of people that are ready to invest. So the short-term solutions that we have for power is only around renewables, except maybe big-time players in terms of investment that can go into all these what we call fast power projects. But the challenge with that, if you are not within the area where you can have the source of fuel, like the natural gas or diesel to power those power plants, you may not be able to execute those projects. But this renewable energy solar power plant, I see a lot of potential in that. And we have not, in Nigeria, we have not explored even 10% of that. I don't know if I answer your question.
Yeah, Jazakumullah khairan for that. Like, I think it's very insightful. So, and thanks everyone. And we're going to have Brother Jawanjo Adewale to give us a closing remark and a closing prayer. So we really appreciate everyone, the facilitator, like they really share so many experience. They share some insightful thoughts with us. And so we say Jazakumullah khairan. So Brother Jawando, over to you, please.
You can't hear Brother Jawando. Hello?
You're on mute.
Okay, he's on mute, right?
Okay. Okay, can you hear me now?
Yeah, we can hear you, sir.
Okay. So I said I would like to show appreciation to our facilitators that have taken time to guide us on the opportunities available in each of their areas. Mr. Shamsuddin Sadiq, Mr. Abdullah Kashim, Engineer Nimat, and I think I missed Mr. Abdulaziz Adam's session, if he's there, because I didn't start from the beginning. What we are trying to do is to improve the capacity of our members. And I think you've given us a lot of insights, which we as a group will be working on. And if there is need to get back to you for support or advice on some of the things we are doing, we will be counting on you that you oblige us. And we pray Allah subhanahu wa ta'ala bless you for the time you have sacrificed today to come and share your knowledge and experience with us. May Allah subhanahu wa ta'ala make this an ujah for you on the day of judgment. Allahumma rabbana taqabbal minna innaka antas samiul alim wa tub alayna ya maulana innaka antat tawwabur rahim wa wafiqna ila al-haqi wa ila tariqil mustaqim. Al-Fatiha. Bismillahir Rahmanir Rahim. Alhamdulillahi Rabbil Alamin. Ar-Rahmanir Rahim. Maliki Yawmiddin. إياك نعبد وإياك نستعين اهدنا صراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا.
And for those that we are unable to take their question, hopefully some of the question will be answered offline. So please bear with us. We are about some minutes over time. So, but some of the question will be answered offline. So maybe some of the question will be directed to the facilitator to answer, and then you will get your answer as soon as possible. Jazakumullah khairan. Thank you for joining, and we really appreciate everyone. We appreciate the facilitator, and we appreciate the attendee. Thank you. Assalamu alaikum wa rahmatullahi wa barakatuh.
Wa alaikum salam. Thank you, sir. Bye.